So let's look at the area first. And so looking at this shape on its own, I don't see an easy way to get its area. It's a quadrilateral, but it doesn't have any parallel sides. So it's not a parallelogram, it's not a trapezoid. It's just a cute quadrilateral. And sometimes with quadrilaterals, we can do things like draw in diagonals to kind of split it up internally to find an area, but I don't see that helpful with that one or this one. So I think we're going to have to take the approach I'd usually recommend on a geoboard, which is that we enclose this in a rectangle as tight as possible. And then from the area of the rectangle, we peel off any adjoining triangles that we don't want here. So let's try. So this is part of a rectangle that is 4 by 3. So starting with an area of 12, start in the upper left here. This right triangle here, we can say has a base of 1 and a height of 3. So we want to get rid of 1/2 of 1 times 3. And then this right triangle in the upper right is 2 by 2. So we want to take away 1/2 of 2 by 2. And we'll say that's the base and that's the height. And the bottom here, we could say a base of 4 and a height of 1. So take away 1/2 of 4 by 1. So let's see, 1/2 of 3 is 1.5. And then 1/2 of 4 is a 2. Another 1/2 of 4 is another 2. So altogether, we need to take 2, 4, 5.5 away from 12, which I think leaves us an area of 6.5 square centimeters left over for that. Yeah, it's a little more than half of that rectangle. That seems like a reasonable answer. Now, for the perimeter, we have one easy side here of 1, and otherwise these diagonals are each longer than 1, and the Pythagorean theorem will help us find them. So for this diagonal here on the upper right, that is part of a 2 by 2 right triangle. So that hypotenuse squared is equal to 2 squared plus 2 squared. 4 plus 4 is 8. And so we want then the square root of 8 for that side. This side down here is part of a 1 by 4 right triangle. So that is the hypotenuse that I want. So the hypotenuse squared is equal to the sum of the squares of the legs. So that's going to give me 1 plus 16 or 17. So my hypotenuse is going to be the square root of 17. And then for that fourth and last side there, it's part of a 1 by 3 right triangle. So the last hypotenuse squared is equal to 1 squared plus 3 squared. So 1 and 9 is 10. So our diagonal is going to be the square root of 10. So altogether, our perimeter is 1 plus the square root of 8 plus the square root of 17 plus the square root of 10. And square roots don't really behave well with addition. So the only thing we can do with this is whip out a calculator. We can't combine those in any meaningful way. One plus square root 8 plus another square root of 17, was it? And 10. And when we type the 17, we're in the root. We have to arrow with the keyboard or here out of the square root to add. And we want another square root with a 10. And we can't combine those. If we tried to combine those square roots, we'd get a different answer. Watch, if I tried to do something like 1 plus, and then inside a square root, try to do 8 plus 17 plus 10, it's a totally different number. So square roots in addition don't behave well together. So that second way is bad math. So it looks like to the nearest hundredth, my version has a perimeter of 11.1. And since each of these horizontal and vertical lengths are 1 centimeter, these are also centimeters for the perimeter. So I have an area 6.5 exactly, and a perimeter of about 11.11 according to my calculator.